Hi, in this video I'm going to go over recursion using this very simple class that has one method in it called recursion test 1. This method takes in an integer called x. The method consists of two parts. This if block, which is executed if x is greater than 0, and then this part down here, which is executed no matter what, but only after this part. Now, if x is greater than 0, it outputs the current value of x, plus it does a recursive call. And in the recursive call, it passes in whatever x is minus 1. So that starts up another version of the recursive method, of this method of recursion test 1. And this line down here is not going to get executed until that newly started up version of recursion test is finished. But that version may make a recursive call, so its system out println x won't get executed till later. So let's just compile this and make a new one and see what it does. We'll pass in 3 just to keep things nice and short. So what it does is this outputs 3, 2, 1. That's the recursion, sort of each successive recursive call. And then, but what's this stuff down here? Well, let's look at some stuff and see if we can figure that out. All right. So here's our first recursive call. This is when we first call this thing, like I just did from BlueJ. In this version, x is equal to 3, and that's what I called it with. And when we make the recursive call, we pass into the next version of the recursion, x minus 1, or 2. Right, so now we start up a new version of the recursion, of the recursive method. This one down here is waiting to finish. It still has this one line to finish. But it has to wait till this second version finishes before it can do that. So in this version, x is 2, right? And so the x2 is greater than 0. So now we do another recursive call. And this time we pass in x minus 1. X is 2, so we pass in 1. Right? So that's this version. We've got a third version running now. Versions 1 and 2 are sitting, waiting to finish. They're on something called the stack, and they're waiting to finish up. In this version, this third version, x is equal to 1. That's still greater than 0, so we do another call, and this time we pass in 1 minus 1, or 0. So now we've got a fourth version. Right? These guys are all sitting on the stack, happily waiting till Java gets back to them. So in this version, x is 0. So that means that this if block will not be, these lines in the if block will not be executed. But what will be executed is this system out println x. Now the x in this case is the version of x that the fourth version of the recursion has. And in that version, x is equal to 0. Each of these versions have their own value of x because that's the way recursion works. Any local variables and parameters are local variables. Each version of the recursion has their own, can have their own values for those variables. In fact, they do have their own values. They may not be different from the values that other versions have, but they're unique to that version of the recursion. All right, so this version of the recursion finishes. And remember, we printed out up to this point. We printed out the 3, 2, 1. Right? We printed out the 3 from this version, the 2 from this version, the 1 from this version. And from this version right here, we print out the 0. Right? Because x is 0 in this version. Now this version is done. So it's popped off the stack, and Java says, okay, what's left on the stack? Ah, okay. This guy's on the stack. What's the value for x? I still have to do this line. What's the value for x for this version of the recursion? Oh, it's 1. Okay, so I will output 1. Cool. This version finishes, gets popped off the stack. We're back to this version. System.out x. X in this case is 2 for this version of the recursion, so we get the 2. That one finishes, popped off the stack. Back to this version. In this version, x is 3, so we output the 3. Again, that's the only thing left to do in this version because we've already done these lines. And the 3 gets output, and then that popped off the stack. In that case, the recursion has unwound. There's nothing left on the stack. This method is finished. Okay, cool. Now, I want to show you why it's really important to make sure that your recursive call, the parameter you pass, parameters you use in your recursive call, approach your stopping condition. In this case, our stopping condition is x that's equal to 0 or less than 0. So let's, instead of subtracting 1 from x, let's add 1 to x. So if we start off with a positive integer here, that means that because each time we call this, we're calling it with that integer plus 1, we're going to move away from our stopping condition, right? And that's going to put a whole bunch of stuff on the stack, as we'll see. So we're going to make a new one of these, and we're going to call our recursion test method, and we'll pass in 3 again, and watch what happens when I hit return. Remember, we're moving away from our stopping condition. Whoops. All right, so this is what happened. We got a stack overflow error. And we see that again. You know what, let's do that one more time. Because it didn't happen quite. I moved the terminal window out of the way, so there. Boom. That's better. All right. So we had a stack overflow error. That means that we kept putting versions of the recursion onto the stack because we were moving away from our stopping condition, right? And eventually the stack ran out. The stack is a special memory structure that Java uses. And stacks are actually used throughout computer science, but this is Java's stack. And it has a certain capacity, and we've overflown that capacity, and we've run out of memory basically, and so it crashes. So always make sure that you approach your stopping condition. I'll just do that because we want to. I want to 3, and there we go. Right. That was left over from before. So 2, 3, 2, 1, 0, 1, 2, 3. Okay. So that, I hope, was helpful. Thanks.